Hello, everybody. Let's look at this problem about driving and traffic density. So I'm imagining a single bridge letting people into a city. It's rush hour. Cars are following a rule for follow distance. So they're going to leave one full car length for every 20 miles per hour of speed they're going. So what it's like at rush hour is the cars are all kind of packed in there. So everybody's going the same speed. So if everybody's going 20 miles an hour, that means there's there's one car length between each pair of cars. If everybody was going 40 miles an hour, there would be two car lengths between each pair of cars. If they're going 50 miles an hour, then there would be 2.5 car lengths for each pair of cars. So in part A, we said, let's model the distance m between two cars. So different people did it different ways. Here's a couple ways you can think about it. So what I know is that the amount of space depends on the speed. So I know there's a half car length for every 10 miles per hour of speed that people are going. If I multiply that by s, the speed in miles per hour, then those units cancel, and that tells me how many car lengths, maybe I should write car lengths, that tells me how many car lengths corresponds to that speed of s, which is not 5. I'm going to really try and make that look like an s. And so that's the distance m. This, of course, is the same thing as saying 1 over 20 s, or s over 20. I'm missing something, though, because, remember, it's 0.5 car lengths, but d is the length of the car. So I also need to get the d in there. So let's put it there. So SD over 20 would be a great model for M. Other people did it other ways. I mean, if you wanted to, you could really try and set up a linear equation and think about it that way. But I think just simple units is probably the best way to think about this one. Most of the thinking for this problem was happening in part B. So let's actually look at that one in 3 different ways. In part B, I'm saying, okay, let's imagine it's a long bridge that's 3 miles long. And again, I've got all of these cars that are driving at the same speed. Let's say all of these little boxes are cars. So this is length D, this is length M. That's length D, that's length M. So everybody's going that way. So here I am, that's me. So I get on the bridge, and I drive at the same speed s all the way to the end, which means that everybody else is also driving at the same speed s all the way to the end. And there's a toll here at the other end of the bridge. And I want to know, what do I want to know? Write an equation for the total number of cars that went through the toll gate from the time I got on the bridge to the time I got off it. So here's the time I got on the bridge. By the time I get off it, I'm here at the toll bridge. So really, I just want to know how many cars are fitting inside those 3 miles. Okay, so let's do this in a couple of different ways. A lot of people were able to just jump straight to the answer by thinking this way. Some people even drew a little picture like this. I said there's 5,280 feet in a mile, and we could just use F because I don't want to focus on the numerical calculations. I want to focus on the concepts. But if we write 3F, that's the total distance in feet for the bridge. So this is bridge distance. So if I want to know how many cars fit in those 3 miles, I need to take that distance that's one car and the space in front of it. And I need to figure out that total distance, how many of these car space pairs fit in that distance. Because each car has a space in front of it. So this distance, let's see, is D plus M. Because remember, M was the space in front. So if I'm imagining this as 1 unit length, I want to know how many of these D plus M distances fit in 3F. So if I do 3F divided by D plus M, and then I substitute in my answer from the previous problem, here M was SD over 20, that gives me D plus SD over 20. So that would be a great answer. A lot of people wrote that down. A lot of people did something that was sensible, but they didn't quite get to an answer. Here, let me look one up just to remember what it was that they were trying to do. Okay, so here's the student answer. They're saying, now this is my comment. So they've got 3F, which remember is the full distance across the bridge. And now they're subtracting this. This was the expression for M, which was the space in front of a car. And they've even said taking away the spaces like between cars. Oh, the distance the spaces are taking. And this is a great idea right here. Yeah, let's remove the distance all the spaces are taking. The problem is this expression M, this was just the length of one space in front of one car. So that's why I wrote you need lots of these. But let's go ahead and follow that same solution approach out to the end, and we'll see that it does the same thing. So we've got 3F is the length of the bridge. We need to subtract. So let's imagine. Here's the length of the bridge. They want to remove all of these distances for the spaces. So that way we're left over with just how much distance is taken up by cars. So let's say n equals number of cars. So what we want to do is we want to do n times m. M is space for space in front of one car. And then once you've removed all the space, all the distance you have left over is distance being taken up by cars. We know that the length of one car is d. So if you take that length that's only cars and you divide it by d, that gives you the number of cars. So here's the thing to realize. Number of cars is what we're trying to solve for. So the way I calculate the number of cars is by starting with the length of the bridge, subtracting the spaces, but the number of spaces I need to subtract is multiplied by the number of cars, because each car has their own space, and then I divide by d. You couldn't leave your equation like this, because we're trying to solve for n, but now let's just use some algebra to solve for n. So I'll multiply by d, so now I've got dn equals 3f minus nm. I want to isolate the n's, so let's add this term to the other side. So now I've got dn plus nm equals 3f. Again, n is the thing I'm trying to isolate, so I'm going to factor that out. So let's do n d plus m equals 3f. And now I'll divide by that term. So I've got n equals 3f divided by d plus m. And you'll notice that that's the same as what we started with over here. So this way of thinking about it works out just fine. You just have to realize that there are lots of these spaces and then use algebra to get to the end there. A third way of thinking about it that at least one person used, I'm not totally done grading them, maybe other people did. They thought, let's think about this as like car density. Let's think about the percent of the overall length that's taken up by cars. So let me draw another picture here. So here's my car, and here's the space in front of the car. And then this basic unit is repeated over and over again. So car and space in front of it. So remember, this is d, this is m. So if I want to think what percent of this space right here is taken up by car, the total length is d plus m, but only a length of d is taken up by car. So the percent of the length that's being taken up by car is d over d plus m. Okay, so if that's the percent of the space being taken by cars, I can multiply that by the total length of the bridge. And so now this is giving me the total length that's taken up just by cars. And so now I can divide that by d, the length of the car, and that should tell me number of cars. So this equation should work also, but let's just convince ourselves that this actually works out to be the same as what I've got over there. So all I need to do is reorganize this slightly. Wow, I wish I'd written this over here. Okay, so let's rewrite it over here. So 3f d over d plus m over d. So remember, dividing by d is the same thing as multiplying by 1 over d. So here I've got 3f d over d plus m times 1 over d. If I write it down this way, you'll notice that D divides D. And so 3f is the same thing as 3f over 1. So here I'm left over with 3f over d plus m, which is that same expression all over again. So we've done it in 3 different ways, ending up with 3f over d plus m, and then 3 different ways of thinking about it. Thinking about it in terms of percent of the distance taken up by cars, so density, divided by length of the car, or like times the distance divided by length of car. We've thought about it as let's subtract away spaces and then divide by the length of the car. And we've thought about it, how did I think about it originally? Oh, right. We've thought about it in terms of the total length divided by how many of those car space units. And all 3 get you to an answer. And I hope this was helpful.